start part D of module 3, exercises and project explanation. Part D.1. I want to use this video to talk about the background of our quiz 3 question number 1. So that is the recurrence stack. In my previous video lectures, I mentioned this, but at that time, I want to save some time, so I delay that topic. Now it is the time. Let me give you the explanation. How to implement recurrence. Because let's first look at our quiz 3 first question. In that question, we need to compare resource consumption. So here we look at the resource. Actually, that should be the space usage resource. We're talking about the space used in main memory. All right, Here, let me use a diagram to explain how it is implemented in main memory. If you have this background, then it is very easy. You can get the correct answer. All right, first, in main memory, when there is a recurrence function call, recurrence function, here let us use Fibonacci function, recurrence function call. Okay, so let us start with this function call. All right. In order to support implementation of Fibonacci or just some recursive function call inside the main memory, there is a special mechanism is used. So that is the basic data structure used is a stack. All right. So you know the stack data structure, right? Very simple. First in, last out, right? So the stack, this data structure has the main property first in, last out. That property. So this property is extremely important for implement Fibonacci or recursive functions. In general. All right, so let us see how it is implemented. All right. Call Fibo of n. Its value is not known because it relies on two previous Fibonacci numbers, Fibo of n minus 1, Fibo of n minus 2, right? If it cannot be determined, then push it into the stack for temporary storage, right? So next, Fibo of n minus 1, still unknown. Push it to the stack for some temporary storage and so on, right? Fn of 2 and so on. Push it, in it, Because only when you have the values or you know the value of the current Fibonacci number, then you can use it to do processing, to do calculation. So that the idea. All right. So then sooner or later, you reach the top, Fibo of 2, Fibo of 1, Fibo of 0. All right? All right. So because these two values are known, so then you pop out, the known values, then fiber of 2 can be calculated. All right, so check it. All right, so then fiber of 3, and so on. That is the typical way to implement recurrence function call, recursive function call. Here we just use special Fibonacci numbers. This recurrence function implementation to give you the general idea. So you can use this way on every recursive function. All right, so with this in your mind, now look at how much resource used. How much resource? Look at the stack, because stack in main memory, it consumes a lot of memory. And the stack, when, think about this, when n is large, very large, so the stack is very deep. Right? The deeper the stack, the slower the implementation, the execution. So think about that. Okay? And there is a possibility, other than the slow execution, so we know the consequence. One of the consequences is the slow execution. All right. Another consequence, stack overflow, right? Have you heard of this terminology, stack overflow? So what's that concept, stack overflow? Because it is too deep and the main memory cannot handle it. The main memory is out of the resource and it cannot handle that deep stack. So some of you may have that experience. So the program terminated and you can see the error message due to the stack overflow, segmentation fault, stack overflow, that kind of error messages. All right. So with this background now, you can see in our question 1, for the same problem, same algorithm, same problem, suppose we have 2 implementation methods, iterative way and recurrence way. Iterative way, we know we do not need a stack, right? Iterative way. So the general, natural way, we can find the solution. But recursive way, this structure, data structure has to be used. All right. But the conclusion, you may have another view on it. The conclusion, we know it consumes a lot of resource. So it looks like a big disadvantage, right? But you have to, sometimes you have to use this way, because sometimes the problem is so complicated to solve. Only when you use the recurrence relation and the recursive function call, you can solve it in a very clean way. In that situation, then you have to use the recurrence implementation. You have no other choice. All right, so with this background, try your best to answer question number 1 of quiz 3. All right, so let me stop here. Yeah.